Okay, so this was last week, and it looks like most of you got the the regular labs done. Um, Everybody here. So just the assignment, the DNS CTF assignment. So the idea here was that you did a assignment. You did one of the labs in the book had you do a zone transfer. So that's basically what you were looking to do here, to find, because the point was that you were going to find a flag hidden in the DNS server's records. And the easiest way, if it's available, if the server is configured to allow this, the easiest way to find the DNS server's records is to do a zone transfer. Now, the reason that this is in the book is because, as a pen testing thing, is because zone transfers, while they're a normal thing that happens between primary and backup, or primary and secondary DNS servers, they should not be configured to just allow anybody to do zone transfers. But in some cases they are. People are lazy, they don't, they couldn't get a zone transfer to work, so they just say, well, let's just allow it for everything until we can get it to work. It's sort of like people turn off their firewall until they can get something to work, and then they forget to turn it back on, right? And they leave themselves totally exposed. So this is the same thing. Or a long time ago, and maybe even with some OSs people are still using, people would install DNS, and it was configured by default to allow zone transfers from just any IP address. Normally, zone transfers are not going to work because the person configuring them specifies only these particular IP addresses, which are going to be DNS servers. Other DNS servers in their network are allowed to transfer the zone. But like I said, sometimes things are misconfigured. So that was your goal, is to just find a record in a DNS server. So let's take a look at what you probably needed to do. Everyone see okay the screen? I think I've got it blown up. Okay. So, obviously the first thing, and really the only thing you can do, is a scan. Let me do a scan that you probably did. I was playing with a bunch of different things here. Okay, so this is a basic Nmap scan, and the -P option says look for port 53 being open, and it's scanning the entire subnet, right? And then I'm piping the output to less so I can page through it. Okay, and as you see, it's going to give you a scan report. You're going to have to go through a bunch of stuff. And eventually you'll find a couple of DNS servers that show where the state is open. Some of the reports will show filtered. Generally, that means that there's a firewall in place, most likely. So that's why, that probably means you're not going to get a response from the DNS server. So anyway, scroll through here. There's nothing open until you get to 205. And so there's a possibility, and then there's another one at 250 right up here. Okay. Scroll right, 250 right here. So there's two open ones, and then 251 says filtered, so that's probably firewalled. Same thing with 252. Okay, so I'm going to show you something else that will probably make it, when you have a very specific scan to do, make it a little bit more, less stuff you have to go through. You can do --open, And that will show you only the results where the port was open. Oh, put it in the wrong place. Okay, and this is, you know, like you didn't have to do this. You could have just done a general scan looking for anything, you know, it'll give you everything that's open and closed. But you know, this is more targeted. And so you see we only get 205 and 250 for results. And that's, you know, narrows it down really nicely so we don't have to sift through all that other stuff. The one other thing I wanted to show you about this, if you notice in the results, let me bring that up again. If you notice in the results, it says 53/TCP open. Now, DNS is generally speaking a UDP protocol. However, it's both. It's one of those very few protocols that use both transport layers, TCP and UDP. The problem with scanning for DNS servers and doing it on for TCP is that you might be missing some DNS servers that are UDP only. You know, that the network administrator said, well, I don't want, you know, I only want port 53 on UDP to be open. So while this works in this instance, I just wanted to show you a little bit more of what you can do with Nmap to refine your results. So unless I've got the capitalization wrong. Yeah, so putting -SU says you want to do a UDP scan. Okay. Now the one problem with the UDP scan is that you're going to get some more results because UDP lacks three-way handshake, and so it's harder to determine whether UDP is open or not. Generally speaking, with Nmap, if it says, if part of the results say filtered, like that first result says open and then filtered, that probably means that it's really not open. And Nmap is a little bit, let's say, not consistent with this because I can run this different times and sometimes it'll say closed filter. So this gives you more than you need, but if you were, let's say, for example, scanning for DHCP, all right, and you just said -P 67, which is the DHCP, and you did it just like that, then you're not going to get any results. Even though there is a DHCP server on this network, you're not getting any results because DHCP is truly a UDP only protocol. So you'd have to make sure that you tell it to scan using UDP. Okay, so you know, leaving out the type of scan, TCP or UDP, it defaults to TCP. So when you just put the port argument -P53, it's going to look for TCP only by default. Okay, let's go back and find our two results that we're interested in. Okay, so we get two results. Shoot. I'm gonna not send them to Les this time so that it stays on the screen. Okay, so now you're like, okay, well, in order to see the records of a domain, I need a domain name. That's the first thing. And so one of these two results gives you a domain name. The 27.250 device has CNT275.local domain. So the thing to do there is to, you know, maybe to scan that address, I can just do a dig on CNT. Let's see, what would you want to do next? Well, probably what I would do is I would go right for the money and say AXFR means give me a zone transfer, and I would query the 27.250 router. I have to put on my glasses so I can actually see what I'm typing here. Okay. And then actually, all I really want to do is I want to specify, I think this will work. Okay, so that's the command I put in was dig AXFR CNT275.local. Now, what you didn't see in this command was me specifying what server to query. And that's because dig will always query the default DNS server that your computer is configured for. And if you don't know what DNS server your computer is configured for, a couple ways to do that: etc/resolve.cnf, resolve.conf. That file, that's just a simple text file that contains the IP address and, if specified, the domain name that your computer is a member of and the DNS server that your computer uses by default for DNS queries. So when we did that dig command, okay, we didn't specify what server to use because dig is going to by default use 192.168.27.250. And I did a zone transfer, and I'm saying transfer the CNT275.local domain. Now, that domain, this is what you did in your exercise, right? In the book, and you, if you did it successfully, then you got all these same records that you got from that exercise. Well, if you look at all these records, nothing really here that screams a flag, right? So there's just, you've seen these before, and there's nothing in here that tells you, hey, this is what I'm looking for. So what I would do is, well, let's go back to the other server. The other server was 192.168.27.205, right? So the 250 server doesn't give us anything we need. The other one was 192.168.27.205, and the problem with that particular server is that there's no domain specified. It just gave me an IP address in the Nmap results. So the thing to understand is a DNS server most likely is going to be a member of a domain. And there's a good chance, it's not always the case, but there's a pretty good chance that that DNS server hosts the domain that it's a member of. So what we can do is we can say we want to dig, and then we specify, the @ says query this server. Okay, so I'm saying don't query my normal default server of 250. Query this particular server. That's what the @ means. And the -x says do a reverse lookup. Now what the reverse lookup is going to do is it's going to basically say if there's a DNS record for the 192.168.27.205 IP address, it's going to show me that host name information and that domain name information. So I don't have that for the 205 server, since Nmap was only using the .250 DNS server to determine domain names and so forth. So the 205 DNS server we know nothing about. So what we're going to do is we're going to say, well, let's see if that server itself, the 205 server, has a DNS record for itself. And so we're going to query it, and we're going to say, do you have a what's referred to as a PTR record, a reverse lookup record for yourself? And lo and behold, we do. You see, here's the answer section. Okay, so whenever you do a query with Dig, a lot of times it gives you a lot of output, and it's basically telling you, I can't help you. But sometimes it's confusing because it always gives you, almost always gives you a bunch of output. But the fact that it says answer one and that there's an answer section, that's what you care about. And as you see, reverse DNS records are basically, they store the record with the IP address in reverse order. And then that's the name. So now we have the name of the DNS server, but most importantly, we have its domain name. So now we can say, now we have another domain we can query to see if we can find a, to see if we can find the flag in those records. So yccnt.local is the domain name. So that's what we're going to try to transfer. I have to go back here and give it the command to transfer. So this command says, do a zone transfer, use server 192.168.27.205, and try to transfer the domain yccnt.local. We still don't know for sure that that's a valid domain that this server is hosting, but there's a pretty decent chance, at least, that since it's a DNS server, that it also is hosting the domain that it's a member of. And then we get a whole bunch of records, and we look at these, and we got some names. If you recognize any of the names there, they're characters from various TV shows. But there's one that kind of stands out, and that's this guy right here. All right, so that's the flag you were looking for. All right, does that make sense?
Yeah.
Okay, so all of this, you know, is just like network troubleshooting, but especially penetration testing and vulnerability assessment is all about tracking things down, seeing, you know, if I was a bad guy, what's available to me on this person's network. And that's, you know, that's really what penetration testing and vulnerability assessment is all about, is you have to think like the bad guys and find out, okay, if I can get into this stuff, then someone else can. So the first thing I would do as a, you know, as the IT guy, or if I was an independent pen tester doing this for a company on contract, I would say, you need to stop zone transfers. You got to go in and configure your DNS server on this address, really on both servers, the 205 and the 250, and restrict the zone transfers, or stop them altogether if you don't have primary and secondary DNS servers. All right. Okay.
So, Greg.
Yeah.
Question, quick. If you're the threat actor, could you said that the DNS server for the zone transfer is looking for the IP of the other DNS server. Could you spoof that?
Could, as the threat actor, could I spoof it? Or
yeah. So, yeah. So could I just go in and say, hey, look, I know that one of these IPs for the DNS server is XYZ. I'll just, try and hit this other one and act like I'm
the
DNS server 1. And then...
Yeah, you could. Spoofing an IP address on a network is not the easiest thing to do because well, computers are configured to pick up IP address conflicts. So if you actually set your computer for that IP address, the actual DNS server that had that address would report an IP address conflict and pretty quickly, somebody would find that there's another machine configured inappropriately. You could probably do things like look for ARP packets, and when if you knew the address of the DNS server, which in this case you would, then when you could set up your computer so with a program that's not where you're not actually configuring yourself as a with that address, but you've got a program running that looks for ARP packets for that address, and then you respond with your MAC address. That would be another way to spoof it. It wouldn't be long before, someone finds out about that, because ARP is also used to do address conflict detection. But it would be, something that you could do and might get away with for a short period of time before, they found out where this ARP is, where this MAC address is coming from.
Gotcha. Thanks.
Okay. Anything else on this?
Oh, I have a little bit of a question from not this particular CTF, but in the book we were doing activity 4.6, and I just had some trouble with that. I was hoping that you could go over it.
Okay, so
I couldn't get my I couldn't get like any of the files to like come up, and I looked in the book and I noticed that none of the actual like what I was looking at as servers had NS next to them. I didn't get a screen cap of it, but I did submit where I was getting like the error message.
Okay, so I think I remember at least some of this, the steps in this lab. So in this lab, you were basically doing what we just did, except you were using CNT275.local as the domain name instead of zonetransfer.me. So in this particular instance, you would just, I think the command was something like -dig ns, and then you were doing CNT275.local. So I think that was the first command that you did. And up here, you get 2 NS servers return. That one and this one. And this one is not going to give you any results. Okay, even though it's a name server for that domain, for the CNT275.local domain, it's not going to give you results because if you look at all the IP addresses here, those are all on different networks than yours, and your machine is firewalled from accessing any other networks, at least these networks. There's some other networks out there, as you'll find out in the next CTF lab, but these you're not able to access. So if you tried to use this guy in the next command, it wasn't going to work. But the only
I couldn't even get those to pop up.
Yeah, well, if you just did that command, that'll do it. I mean, my machine is configured exactly as yours is. And then the next command that you did was the zone transfer, and you were saying use, the IP address that you found, or you could even use the domain name in this case, but I'll use the IP address. And so, because it's quicker to type. So so that's basically saying, query this server. This is actually unnecessary in this particular case because the DNS server that your computer is configured for is this address. But it's good practice, for you to know that when you want to query a DNS server other than the one that your machine is configured for, that this is the syntax, @ and either the domain name or the IP address of the server. And then the next part of that syntax is just the domain that you want to query, and that gives you, boom, all those records. So,
Okay.
yeah.
Jillian, I ran into an issue too, and it turned out to be that I wasn't leaving a space in between the AXFR and the @ sign. Sometimes in the text, and even when you're reading it in the on Canvas, the spacing isn't really clear. So I just found that I would like go back and trial and error and add spaces in, and sometimes that
Okay.
was.
The other thing to
Yeah,
do
definitely could be it.
to make sure that your syntax is good is, look at the man page. Here it says dig @ server. And then, down here in the man pages, it gives you more, server is the name or IP address, the name, sort of blah, blah, blah. Okay, so it kind of gives you a hint as to the syntax and the spacing necessary if you look at those man pages. They're not always, super well written or easy to follow, but for Linux, this is it in terms of help at the command line. So you're only helping yourself if you get used to looking at man pages or help streams, and not just for Linux, but if you're going to do work on a Windows server or even a Windows client station in a like cybersecurity capacity, you're going to use things like PowerShell a lot, and you need to know, use the help system in PowerShell, and it's similar to this. It's got a lot of syntax it shows you, and you got to just kind of decipher it. And once you've looked at a bunch of help streams, they get easier to read as time goes on.
Okay.
Okay, so anything else on the DNS stuff, dig stuff?
Not related to DNS, but are we going to do anything with the Windows 98 and XP computers?
You mean as far as doing something bad to them?
Possibly.
So you know that those machines are out there because of the scans, right?
Mm-hmm.
Right. So yeah, I've been working on. It'll probably be another couple weeks before we get to that. But one of the tools that penetration testers use big time is Metasploit. Have you heard of Metasploit? If you took the CNT175 class, the Security Plus, you've probably at least heard of it, even if you didn't use it. But yeah, we're going to use Metasploit, and one of the challenges of coming up with a lab, and I understand that this is probably why you don't see it very much in these books. I mean, I've looked through a lot of books, and I've been having a hard time finding a lab. So I just got to write my own that walks you through compromising another computer, and in an understandable way, hopefully. So the goal with one of our activities is going to be probably start off with some really simple, basic Metasploit stuff first, because it's a monster and it's complicated or complex. I don't want to say complicated, but it's complex. But anyway, the goal will be with that XP machine that you see there, is going to be, we're going to basically get basically command line access to it and be able to basically take over the machine if we want. And it's not through stealing a password or anything like that. It's going to be from a known vulnerability in Windows XP, Windows XP Service Pack 2, even Service Pack 3, known vulnerability that allows you to take over a system, basically get what's called a reverse shell. And then once you get a reverse shell, it's almost like you're telnetted into that machine, and you've got better than just telnet user credentials, you've got essentially system credentials or administrator credentials. So yeah, we're going to work towards doing that. And that XP machine there will be one of the targets. there's actually 2 XP machines. I think one we'll do a practice on, and then the other will, I'll let you do the actual CTF exercising. And I think maybe, if possible, do one for a more recent operating system like Windows 7 as well. Probably it's a little bit more complex of an exploit, but it should be doable. But again, one of the problems is finding an operating system that has not already been patched for these exploits that let you, really take over the system. But I do know that I can do it with some of the machines that we've got here. So, all right. Any other questions before we look at next week? All right. So yeah, Metasploit is, kind of like, if you become expert in that, then you're a pen tester or a hacker, depending on which direction you want to go. Okay, so chapter 6, we've got. I didn't see a lot of tools in those in standard activities that were actually going to be useful or even work appropriately. So 6-1 is the only one that I'm having to do. It seemed to work okay. So I left that in there. And then I have you, just do another scanning exercise using Nmap, just to give you some more practice with Nmap. It doesn't really say what to use, but hopefully you know that that's what you should use. And I'm just looking for, pretty simple. Looking for those 2 services to be open on a computer or one or more computers. And
you said service version in that scanning exercise one. That's actually like the SSH version. It's not looking for like the Windows version or something on the machine.
Right, it's the SSH, the version of SSH that's running. And the reason that's important, you're going to have to look at the help of Nmap to get that, to figure out what switch tells you the version. Or, there might be, some encompassing Nmap options that, will show you the version without the specific option specified. But either way, you'll the ones that we've been doing don't give you that much detail on the service. But so I'm looking for the SSH version and the SMB version. And the reason, like I said, those are important is because once you start, doing more serious, trying to exploit vulnerabilities, tools like Metasploit, you need to know, or you need to tell it even, what version of the service that you're trying to exploit. Because there'll be different exploits for different versions. And sometimes, a certain version of a service, it doesn't have any exploits because they've been all patched up. So that's why you need to get the version to see, hey, is this even vulnerable in the first place? At least vulnerable to the extent that I want to waste my time playing around with it. So that's the reason for that activity. Okay. Has anybody looked at the assignments for this week?
Yeah.
Okay. What did you find? Did you try anything yet, or have you just looked at them?
Yeah.
What's that?
Yeah. I got through most of it. I'm onto the CTF trying to look for flags.
Sorry, you did what?
Yeah.
So you did this one? The discover the network?
Yeah.
Okay. And then you're on to the next one, which kind of builds on this one. Okay.
Yep.
Because if you don't do this, if you don't get this one, don't bother looking at the next one, because you won't know what to okay. So you figured this one out. I think I give enough information in here. Maybe I'm giving too much information.
It's just the right amount.
But yeah, you know, by telling you some of in some cases, you know, what the skills are that you need, and giving you a little bit more information, background reading. If you're not doing the background reading and you're not able to get the CTFs completed, go back and do the background reading, because I give a lot of hints in that. It's only when the background reading is just a web link somewhere where, you know, it may not be a direct hint into the activity. But when I write a page for the background reading, like I did in this case, then there's a pretty good chance that there's, you know, something useful in that page. In this one, you know, in this particular case, it's not a very detailed one, but the next one has a little more details that you'll want to pay attention to. So did you do 5, Chris, or not?
Just starting.
So you just started on this one? Okay. Okay, so this one, you know, this one's going to there's a good chance this one's going to take a little bit longer. I'll give you, you know, an idea that you're going to, in the past, when you've had to look at information, it's been a reasonably small amount of information, and you didn't have to dig too far to find what you were looking for. In this one, there's a fair amount that you're going to have to go through, and that's partly because that's the nature of it. When you're doing a scan of something, and you're just looking for vulnerabilities, or you're looking for a way in or whatever, you know, people will tell you, or literature will tell you, sometimes you're spending days or even weeks just getting the information before you can actually start, you know, acting on that information. I'm not going to make you work for days or weeks, I hope. But, you know, maybe, you know, 10 minutes here, 30 minutes there, maybe sometimes longer if you're not, you know, if you're floundering a little bit. And that's hopefully, you know, failures, you'll learn as much from not figuring something out, or at least failing 5 or 6 times before you do figure it out, as you will if, you know, someone handed it to you. You probably learn a lot more that way, by repeated failures before you finally succeed with something. So here, again, just to recap, this one here has you find out more about your network. Right now, all you know about is your own subnet. And, you know, you can access the internet, but you only have port 80 and 443, and you're not, under no circumstances should you be scanning the internet. You know, shouldn't be going out there to public IP addresses. You really won't have much success because, like I said, I've only opened those 2 ports, so you can open a web browser and Google stuff, or you can open up a Canvas window and submit assignments within your virtual machine. But I still don't want you to even try to, you know, because that's part of, you know, the education process is you learn stuff, but hopefully in a fairly safe environment where you're not going to cause any damage to a production network. So you're going to find the other networks in your internetwork, and I'm looking for you to send the network ID and subnet mask of each network that you find to this assignment. And then assignment 5 is I wrote a little help or a little background reading about ping in there, maybe some information you didn't know about ping and how it worked. Ultimately, there's 3 flags. You got to find the first. Honestly, you have to find the first before you can before you're likely to get to the second. Well, that's not necessarily true. You might get to one of the others before you find the first one. But you definitely, I would be very, very surprised if you're able to get to the final flag without doing a little, you know, kind of checking out the clues and following the clues. to figure out how to get that third flag. Here I'm giving you a little bit less information. I'm not telling you what the specific targets are. So you're going to scan, presumably, these networks once you find out what they are. And you're going to find a few potential targets with some networking services that are running and open. Some of them will lead you nowhere and be useless. Others, you know, might get you somewhere. So if you follow the clue given in the ping part of this assignment, you probably won't have to waste too much time in figuring out what your target is, or at least not which particular device your target is. Maybe you'll still have to mess around to find out what the what service it is that you're trying to exploit. All right. Any questions? Is there any? I mean, do you have at least an idea of where you're supposed to start with? You got to start with 4. I'll tell you that. Got to start with 4, but kind of gives you an idea of what you might be looking at. And you know, harken back to your Cisco days, learning about, you know, as I say, routing and routing protocols, and you know, how does that play into security, routing and routing protocols? Some of the things that you do in the configuration of the routers in the CNT140, 150, 160 class, you know, there's a reason why you do those things, and it's because if I'd configured, let's put it this way, if I'd configured the router the way I should configure it, you wouldn't be able to find out this information, okay? but that's the point, is IT people are sometimes lazy, and they don't configure things the way they should, or they really don't know how they're supposed to configure them to be secure. And so I'm, you know, doing as much bad configuration so that you know, get information that might be a little bit harder to find if I didn't give you this extra little piece of tidbits of information. All right. Anything else? Chris, thanks for pointing out that question in last week's quiz, I think it was. Yeah, that was just a flat out wrong answer. But in Canvas, when when a question has an incorrect answer, I can go in and make it correct the answer, and it will regrade the people's tests or quizzes. So anytime you find that happens, I do not, since these quizzes are taken, excuse me, from a pre-made test bank, I don't, you know, I look over the questions because I read some of them out, but I don't do a real fine tooth comb and make sure that every, you know, question has the correct answer selected. And so occasionally you'll find where a question just has the wrong answer marked. And when you notice that and you got it marked wrong, just let me know and I'll fix it.
One last question on the exercises for this week. When the clue is talking about ping messages containing, you know, messages that one IT person could send to somebody else or whatever, all that stuff you would be able to see on Wireshark kind of by taking a look at the packet?
Yep.
Okay.
Indeed. Obviously, with these, you know, kinds of activities, capture the flag activities, you know, you need to be on the network that you're trying to exploit. But there's, you know, in a lot of cases, you know, some of the biggest attacks have been where the perpetrator got onto the network, and then from being on some way, some backdoor or some way onto the network, then they were able to use these other tools to gain more information about the network to know further, what should I go after. So getting, you don't have that piece yet, getting onto the network, because you are on the, well, at least you're mostly on the network that you're attacking, so to speak, or at least that you're scanning. But you can scan remote networks using Nmap and other tools. You just can't, let's say, capture packets. Okay, you're not going to be able to capture packets that are strictly between one host and another, and both those hosts are on a remote network. You unless you have access to the infrastructure devices, the routers and the switches, to be able to, let's say, port mirror ports within a network, you're not going to be able to capture packets that are on a remote network. But you can capture packets going from one network to another. If one of those networks is yours, then you can capture those. So, all right. Anything else on what's coming up?